Page, intersecting chords and secants. Now we will do the proof, I think, in coming lessons, but for now let's just understand the concepts and start applying them with some problems. So this is our first problem here. We've got this circle and we've got these two chords cutting one another. We're told this length is 3 and it's equal to this length, so that means that length is also 3. This length is 2 take x and this length is x squared. Now the rule here that we're going to prove is that when we have intersecting chords, that ax times bx is equal to cx times dx. So straight away we're going to come up with an expression here for that. So we've got ax is 3 times bx is x squared, so we've got 3 times x squared is equal to, this we've said this side is 3, cx, so 3, and then times by dx is 2 take x. Alright, so straight away we've just extracted the lengths and come up with an equation. And now we're going to solve this. Alright, so what we want to do is expand it. We're going to have 6 take 2x. We're going to move all to the left hand side. We're going to have 3x squared plus 2x take 6 equals 0. So we're trying to find the values of x that satisfy this equation. So from here, there's like a number of procedures we could follow. What have I got?
3x when you expand the 3 to 2 minus.
Yeah, it's 3x, not 2x.
Should be
6 minus 3x. Thank you. Thank you very much. 3x squared plus 3x takes 6 equals 0. So now we want to solve this equation, all right? Now from here, there's a number of ways that we could go about solving this, and that's what we've been learning in our other maths at the moment. Because this here is a quadratic, okay? We can tell because the leading term is x to the power of 2. So we know if we want to solve a quadratic, like what are the possible ways we could do it? We could factorize it, we could complete the square, we could quadratic formula, or we could use our calculator. So there's like four procedures we could use now, okay, from here onwards. Let's have a go at factorising it. So multiples of 3x squared are going to be 3x and x, and multiples of 6 minus 6, we need 2 and 3, and I think like this, isn't it? Let's see, so when we cross multiply here, we're going to get minus 3x plus 6x, and when you add them together, you've got positive 3x. So these are our solutions. That's factorising using the cross product method. I hope we're pretty competent with that. If you're not, let me know. I can get heaps of stuff for you to practice. So then we're going to have 3x take 3 times x plus 2 is 0. And so our solutions are 3x take 3 is 0, x is 1, or x is minus 2. Okay, one more step. Any problems with our answers? Got 2 answers. Think about the context of the answers. What have we found? Look at them. One of them is a positive 1 of them is a negative 2.
You're not having a negative length.
Well, that's correct. We can't have a negative length, so we need to reject this solution. So there's only one solution. So this is a solution mathematically, but it doesn't make sense in the context of the problem. You can't have a negative length. So we're rejecting that solution. This is our answer. We weren't given any units, so we're fine to leave it like that. Okay? Cool. Let's move on to the second example. This time we're applying the secant tangent theorem. So here's what a tangent is. Okay, we've said tangent is parallel at that point, and a secant is like a chord, but it's extended. Okay. Now the rule here is that this length xt squared is equal to xa, so that length, times xb times the whole length. Now the question here, xt equals 6 centimeters, find xa. xt is 6 centimeters. xa is 4 centimeters. Find xb. So we're just going to substitute them into the formula here. So we've got 6 squared equals 4 times xb. And then we're just solving this. We've got xb is 36 on 4, 9 centimeters. Alright? So if xb is 9 centimeters, what is the length of AB? The chord AB.
5 centimeters.
Excellent. This whole thing is 9, this is 4, so this length would be 5 if it asked you that. Okay, so that's enough to get into these questions, intersecting chords and secants. Let's give it a crack.